Welcome back to day 7 of Learning Fusion for the DFT 154 class. Today we're going to cover polygons and threads. So we're going to show you how polygons work and talk about the difference between subscribed and inscribed polygons and why you would use one versus the other. And then we'll show you how to use the thread stuff, which is very easy. This probably will be a short video because I just wanted to show you these two before I gave you your second project. And then after this, we're going to skip into irregular shaped objects. Most everything we've drawn so far has either been circles or squares. Today's going to be a little bit of circles and polygons. And then in the future, we're going to draw some more advanced pieces. So for today, we'll back up. For you, you should start right here in the main screen. I'm going to turn off the data panel just to give me more room. So we're going to, first off, is save our drawing. So we'll come up here to save. And then we're going to call this one the bolt. Make sure you're in your folder and then hit save. I'm going to change the units. So come right here below where you just named your project, where the units are, hover over it and you'll see the pencil appear. Click on it, and then when the dialog box on the right, change it to inches. And then hit OK. Don't worry about the set as, just hit OK. And save it again, just so we keep that. Alright, so what we want to draw is a just standard hex head bolt. I'm going to do a hex head bolt, and I'm going to do a socket head bolt. And I'm going to show you a couple features there. So to start with, always go to Create Sketch here in the top left with the green plus. And for this one, again, we're just going to pick the X, Y axis. We'll have a top-down view. And we're going to start with the head of the bolt. So this is going to be a hex head bolt. That's a 6-sided polygon. So if we come up here to Create, and then come down to Polygon, and you'll notice there are two options where it says Circumscribed and Inscribed. And if you'll notice from the picture right beside the cursor, one of them references the distance from the center point to the flat surface, and the inscribed references the center to the outer tip. So I'm going to click on Circumscribed first, and we're going to use our origin as our starting point. So hover over the origin till the blue box appears. Click on that and drag out, and you'll notice that my measurement is in reference to the middle of the flat. So if we think about this, and I'm going to, we're going to call it, let's do a 1/4 inch, and you'll see why in a second. So now I have this 6-sided polygon. If I were using a wrench, it would go from flat to flat. Therefore, this should be a 1/2 inch for a 1/2 inch wrench. So that is a circumscribed polygon. Whereas if I did an inscribed polygon, I'm just going to click around the space. Notice it's now from the center to the tip of the polygon. And there may be times that you want to use this for what we're going to do today. We're going to use the circumscribed, not the inscribed. So if I did the same thing here, I did a 1/4 inch. If I measure from flat to flat now, I'm going to get an irregular number, 0.433. Because it's referencing from the center of the polygon to this corner rather than from the center to the flat edge. So just think about that when you're choosing which one you're going to use. I'm going to delete both of these and we're going to start over. Alright, so we've already saved a drawing. We switched our units to inches, so we hit Create with the plus and then select our XY coordinates. So from Create, go to Polygon, and we're going to do a circumscribed because I want flat to center so that I can get the head size of the bolt. And real quick, before I do that, let's see what a standard head size. I can't remember which wrench is used for a 1/2 inch. Okay, so it says, just from this one, we're going to use this as an example. For a 1/2 inch thread, it's a 3/4 inch wrench. So we'll go back into Fusion and we'll do our polygon, circumscribed, and then I want to try to keep this just to keep it orientated. I started with the origin as my center and I'm pulling out directly down the x-axis. You'll notice the blue line that's appearing between the origin and my cursor, meaning I'm directly horizontal with that. And then this is going to be a 3/4 inch wrench size, but notice I'm from the center to the outer edge. So the 3/4 would be from one side to the other, so I got to half it. And I'm going to let Fusion do the math for me, so I'm going to type in 3/4 and then divide that by 2. And then if we do our inspect feature, go from one side to the other, there's my 3/4 inch. And that's what we wanted. So now I've created my polygon. I'm going to hit the letter E for extrude. I'm going to rotate my screen, and then I'm going to pull the head of the bolt up. Let's say, see if it tells me. So it says 11/32 of an inch right there. So let's do 11/32. And now I have the hex head of the bolt. Now we need the shaft part. So I'm going to do create sketch, green plus, but I'm going to click the top surface of this polygon. So not one of the origin planes, but the top surface. So make sure you select that. And then this is going to be a center diameter circle. We'll put right on the center of the origin. We know that's the center of the polygon we just created. And then we're going to, this is a diameter, so we're going to punch in the 1/2 inch, 0.5, or 1/2, either way, for the shaft. Now we need to extrude that up. We're going to make this a 3.5 inch bolt. So we're going to hit E for extrude, select the center portion, and then pull up and type in 3.5 inches. So you'll notice that the bolt is appearing right here. Now, polygon was the first one. I said I was going to mention threads. Threads are super easy. So we're going to come up here to create. And notice that we're no longer in the sketch menu. We've gone back to the solids. We can see the blue figures here. Go to create, scroll down, and we see threads. So we're going to click on that and then hover over the shaft of the bolt, and it's picking that surface. And when we click it, it's going to kind of auto determine what we're looking for here. So it already knows that that main shaft was 1/2 inch, so it's looking for the 1/2 inch sizes. Those of you who have been in either the maintenance or the mechanisms class, we talked about whether the UNC, UNF, so coarse thread versus fine thread, 1/2 inch. The coarse thread 1/2 inch is typically a 1/2 by 13. So I'm going to hit this drop down menu right here, and you'll see the 1/2 by 13 UNC, or unified coarse threads. So that's what we're going to click, and notice that it has now threaded that shaft. The only other thing is I don't want it to be the full length. So the bolt that I've been working with this week was the shear pin for a bush hog, and it's only got about not even an inch, maybe 3/4 of an inch worth of threads. Notice that it is modeling the whole length of the shaft, and that's because right here full length is selected. So if we uncheck that, then it's going to ask me, well, what distance do you want to go? So what we're going to tell it is, let's see what 3/4 of an inch looks like. That's too much. Let's go with 1/2 an inch, 0.5. And then I want to, this may slow your computer down. I'll show you why in a minute. I'm just going to do this for a second. So we're going to we make the 1/2 inch bolt, 1/2 by 13 unified coarse thread. We've selected it to be a length of 1/2 an inch down. And we're going to hit OK. And it's going to thread, actually it messed it up. Let's go back in here. I don't know, oh, we did an offset, that's why. That's why it didn't look right earlier. So sorry about that. Ooh, not 3/4 of an inch. Where's my, 3/4. I think this is what I was going for. So sorry if you had to backtrack a little bit. And then what I want you to notice is with threads, you can tell it's sort of threaded, but it doesn't really look like a thread. What the next step we're going to do here is going to maybe cause a little bit of lag to the computer, but it just gives you a better visualization. So modeled, if we click modeled now, it looks like a thread, but it requires a lot more power from your graphics card, so that may cause a little lag with your computer. When we're just designing, we leave the modeled off because we don't really care what it looks like, but for visual purposes on mine, I'm going to turn modeled on and then click OK, and you'll notice now I have a 1/2 inch by 13 TPI thread that is 3/4 from the tip, and this looks roughly like it looks in real life. We're going to add a few more things here. If you ever look at the bottom of the bolt, this edge right here always has a curved fillet to it, so we're going to go on and throw the fillet in. So if you click right here, and it's a small fillet, it's not very much, we're going to call it 0.025 of an inch. Hit enter. And then there's always some markings on the head of the bolt, usually specifying the grade. If you've been in maintenance class, again, we talk about the markings for the grades, whether it has 3 marks or 5 marks or no marks, representing grade 2s, grade 5s, and grade 8s. To show you what that looks like for anybody who hasn't seen it. This is what we're talking about. So grade 2 typically has no markings, grade 5 typically has 3, and a grade 8 typically has 6 marks. I said 5, excuse me. We're going to consider this to be a grade 5 bolt, so what we're going to try to mimic is this right here. 3 marks equally spaced around, so we're going to use our circular pattern to create this. So we're going to do a create sketch. We want this surface of the bolt. You may need to orientate it so you can see it. Get this top surface, click on there. And then all I'm going to do is I'm going to create a mark. I'm going to do a construction line. So I click the line here, you can press L and then the construction or X. Start right here in the center just to give me a reference directly up here. And we're going to pick right there, looks good. And then we'll hit escape. I'm going to offset that line. And I'm doing this visually so I don't have technical measurements, but let's say, let's go 0.02. I think 0.02 will be okay. This way, and hit enter, and then offset the other side. So it'll be negative 0.02 in the other direction. And notice now we've created kind of a little pocket here. I'm going to turn both of these lines into solid lines. So I'm going to click this one, and I'm going to hold the shift key and click the other one that selects them both. Come over here to where the line type is and turn the construction off, and notice they both went to solid lines. Now I'm going to close it in the top. So I'm going to draw a line again. I'm going to press L as the shortcut. Notice the line icon is below the cursor, and I'm just going to snap on to the top of the left side line. Notice the blue box that appears. Click it, release, and then drag over to the other side. Snap on to that one. Click again. Now I left construction on. You need to turn that off. But if you do like I do and accidentally mess it up, just zoom in, click on it, change it back to a construction line, and then see how it's currently in construction. So I'm going to press X and turn that off. And now what I'm going to do is do an offset for this top line. And notice how it's trying to pick up everything. We talked about this in the last video. This is where you have chain selection on. I only want the top line. I don't want all of it, so I'm going to turn the chain selection off. Now I should be able to select this top portion. And we're kind of doing this visually. So let's say it's a little too big. We'll do 0.125, which is 1/8 of an inch. And hit enter. So now I've got my little kind of square right here. You'll see what's going to happen in just a second. And I want to trim up these bottom two edges. I don't need them. I want to make sure it doesn't pick up on them on the extrusion. So we're going to hit the trim feature. That's either under modify, trim, you can press the letter T, or it's these little scissors right here. Click on that, hover over the line. The part that's red is going to be trimmed away on both sides, and I'm left with this little pocket. Now you can do this two ways. I'm going to show you both real quick. I can do a circular pattern for this feature. So we'll come to create, come down to circular pattern. It's asking me which objects you want to do. Because these are 4 random lines, I've got to select all 4 of them. And then the center point, we're going to hit select beside center point to switch over. The origin is my center point, so hover over that until it latches on. And then it's 3. I wanted a grade 5 volt, which if you remember was 3 markings. There you go, you can see it here, but it looks like that. So I can do it this way, and then I hit enter, and then I can extrude these 3. So hit E, and I only want to select these inner pieces, so 1, 2, 3. And I'm going to orientate my screen so we can see what happens. And they don't have to be very tall. That's probably actually way too tall. So let's half that. Let's go to 0.025. It's still too tall. Let's do 0.01. There we go. We just want to see a marking. That's really all it is. And hit enter. And now I've got a grade 5 marking on my bolt. And you'll also notice from most of them, it's hard to tell from this picture, but notice there is, what it is a chamfer, a small chamfer right here around all these objects. So let's try it. It may actually be a fillet, but we're going to see what happens if we do this. Yeah, that's not what I was going for. What it's actually doing is a little more complicated. That's why it doesn't look right. But we're learning, so let's just go and try. It's actually a cone-shaped piece. We haven't learned this feature yet. So I'm going to do a create sketch, and what I need to do is draw a circle. Just outside of my pieces there. And what it is it's creating a chamfer coming off of that circle. This is going to introduce a new feature you haven't quite learned about yet. Actually, let me try one other way. Sorry guys, I'm kind of showing you a little trick in a weird way. We're going to do, let's try this. Let's do an extrude down, but we're going to do a tapered angle. Let's try, it's 20 degrees. 10 degrees, going the wrong way. Let's try 85. Did that do what I wanted? No. It's not picking up on what I wanted to do. It would actually be a revolve feature. We have not done a revolve yet, so I don't want to overcomplicate things just yet. that would work if it would go all the way to the outer edge, but it's trying to center it up, and that's not what we're going for here. Alright, so for right now, we're not going to worry about that, so sorry if you have tried to go that far with it, don't worry about it. I'm going to hit delete to that sketch. Anyway, there is our, just a basic bolt right here. So there's our markings we used. You could have used an emboss or an extrude for our 3 markings to represent a grade 5. Polygon, circumscribed to do the hexagonal shape, and obviously you could pick any size you wanted. So to show you what that dialog box looks like, well, we're already in it. I'm just going to draw another sketch on a different one to show you any polygon you could have chosen. So circumscribed. Notice that 2 boxes appeared. One is showing the radius, 0.515. The other one was showing the 6 sides. So if I tab over, notice the 6 right here. Let's change that to 4. Whoop. There. So now I created a square. I do 5, create a pentagon, a hexagon, so forth and so forth, octagons. So that's what's happening there. If you can do any side, you could do 3. You could create a triangle. That's where the polygon feature works, and then you can change your different radiuses. So any kind of polygon you want to do there, I just want to show you that's how it worked. There we go. I am going to do one more thing. Most bolts have a slight taper, and this is a cool one about the timeline. Let's see if this will work for us. I want to do a taper of the end of this bolt, just so it starts easier. But the taper should be uniform around it. And let's watch what happens. We get out of sketch mode. We go to chamfer. If I click on this edge, you'll notice that it's going to look very irregular. And that's not what we're looking for. So if I drive that in just a little bit, and it's actually doing all the threads, I don't want to do that either. So this is where your timeline down here becomes important. So I got threads there, but I want to chamfer the outer part of the bolt. So I can actually roll back before the threads. Notice now we have a uniform shape. So I slid the timeline bar back. And then I'm going to do a chamfer. So modify, chamfer this outer edge. We're going to take it in just a little bit. And we're going to make it a little, we're going to do an angle, distance and an angle. Because I want it to be a little bit sharper and not nearly as deep. So let's go with only 0.02 deep. And then the angle we're looking at right now is 60 degrees. You can type them up here too. So 0.2 is the inward amount, 60 degrees, and then hit OK. So now we got a chamfer, no threads. If I come back down to the bottom where the timeline is, and I grab that timeline bar, I slide out, now I have my threads back and a beautiful taper. And it messed my threads up. Wonderful. So there are some little quirks to it. That did not quite work like I wanted. I'm going to take the chamfer out. I wanted the threads to go all the way to the end. But you could see how the timeline bar worked. Wonder what would happen if I did my threads second. If it's going to finish it out or not. Let's do our half by 13. Model it. Yeah, it's still messing it up. offset -0.2, what would happen? It doesn't like that. Can't be negative. Okay. So we'll leave the chamfer off. I'll play with it once I get that corrected. I'll let you know. So anyway, there's our bolt. I think I changed my length. I think it's supposed to be 3/4. Yeah. So that is polygons and threads. I'm going to do another one while we're in here. Let's do a socket head bolt, which is a rounded bolt. It's like these, very common. So notice that the polygon or the hex head is inset into the bolt instead of being on the outside. So we're going to try to create this one now. And we're just going to do an M8. Actually, we'll do an M12, so the two bolts are the same size. Alright, so if we do a circle, and we come over here, we're going to, this one obviously is in reference on the origin. I just want to show you kind of how things look. So we're going to draw a circle out in space. And before I do that, let me see. Let's do M12 dimensions. Okay, there's our M12. So notice we have an M12 by 1.75. That is our nominal diameter and thread pitch. And then we've got, there's our radius that we did on the last one, the depth of the polygon, the overall size of the head, the depth of the head. We're just going to round up. We're going to call this 18. We're going to call that, we'll make that 12. So let's try that. So we're going to do a circle, center circle diameter. Just come out in space. I've always told you to reference the origin, and you should. That's a good habit, but you don't necessarily have to. So what did I say? That was a 18 millimeter. And notice, I want to do this because I wanted to show you this feature also. So I'm in inches. So I had set my units to inches, but now I'm trying to draw a metric size. You can do that without switching the units. So this was supposed to be 18 millimeters. So if I type in 18 and then mm, get the capitalized off. There we go. You type in 18 mm, it automatically switches. Even though I'm still in inches, it goes to millimeters. So I typed in 18 mm for millimeter, and it's going to give me the inch equivalent, which is fine, but it's just a way of drawing a metric inside of a standard or a inches drawing. So what we're going to do now is we're going to extrude it. We're going to hit the letter E, and we're going to extrude down. And that is, we'll just call it 12. We'll make it 12. So again, we'll type in 12, and then mm. So now I hit 12 space mm. You need the space between it, and that's going to create a millimeter again. Notice it's giving me a standard depth. That's fine. Then what we're going to do is we're going to create the shaft underneath. So we'll do create sketch, click the bottom of this head, and then we're going to draw the 12 millimeter circle. Now, when you go to the center of this object, you should see this blue circle appear. Right there, that's telling me that's the center. It's like locking into the origin. It's just picking the center of this circle, still doing the same thing. And then this is going to be 12 space mm, because it's going to be a 12 millimeter bolt. Hit enter. And we're going to make this one, let's say 50 millimeters long. So hit E for extrude, click on this intersection, pull it up, and then I'm going to type in 50 space mm for millimeters. So that's creating a 50 millimeter shaft. Alright, so there's the basic shape of my socket head screw. Now to do the threads, we're going to come over here to create, go down to thread, and then click this shank right here. And I'm going to turn on model just so you can kind of see what's going on. And notice that it picked up a 1/2 by 12. Because we're in inches, it thinks that this is roughly a 1/2 inch shaft, but that's not what I want. I want a metric shaft. It's supposed to be M12 by 1.75. So where the ANSI unified screw threads is, click the drop down menu, and we're looking for the ISO metric profile. Notice now it says, okay, well that was a 12 millimeter shaft, so we're guessing you want to go with the M12 by 1.75, and that is correct. That is what I want. Also, in this case, we're using a standard bolt of a right hand thread, but if you wanted to change this to left hand for backwards threads, these are fits and different things like that. And well, we're not going to quite model it full length, so we're going to take the full length off, and we're going to give a depth. But notice it's now picking the wrong side of the shaft, which does happen from time to time. And this does not have the flip feature on it. But what we can do is offset the 50 millimeters and then change the direction to the opposite way. Oh, 50 millimeters. And then that's the offset though. And then the length, let's do 48 millimeters. Try it to be negative. It's not going to let me do that. Okay. So what we're going to do, we're going to do some math in our head. I want 2 millimeters between the bottom of the head of the bolt and the threads. So what we're going to do is an offset of 2 millimeters and then a thread of 48 millimeters. I don't know why that's not quite working. This is what I'm looking for right here. So that left a 2 millimeter gap up here, and then a thread all the way out to the tip. Hit OK, and this is what it should look like. And if we go back to our drawing, notice there was a radius of 0.6 millimeter fillet at the base of the head. So we're going to zoom in to right here. We're going to go to fillet under modify. So you can either click on modify, go to fillet, type the letter F, or click on this symbol here. And then we're going to do a 0.6 space mm for millimeters. And then there's our shank part right there. So we're going to hit all OK. Now I want to change it. I don't want this little bit exposed. Since that was 0.6, what I'm going to do is go back to my threads. I'm going to change my offset to 0.6 mm. Yeah, that's what I want to see. And then we just need to make sure our threads go all the way to the end of the shaft. So we're going to grab this arrow and just pull down to the very end. Hit OK. Now that looks the way I want it to. There's my fillet at the top. If you don't know what that's for, when you get into the maintenance mechanisms class, we'll talk about it. But a sharp edge, a sharp 90-degree corner creates a fracture point The fillet disperses that stress load over a larger area and makes the bolt stronger. Alright, so there's our basic shape. Now we need to put the hex head inside of it. And let's go back to our drawing. It says that this is a 10 millimeter. It should be a 10 millimeter Allen key that goes in here. So we're going to go to create sketch. We're going to pick the top surface of this bolt. We're going to zoom in a little bit, and then we're going to go to create. Come down to polygon. Remember, we're doing circumscribed because we want center to the flat, because that's how big the wrenches are. And if you do hover over this center portion, because there seems to be nothing there, if you do hover over and it doesn't come up, go to the outer edge, let it latch on, and then come back to center. It should be there. So once you find that, click it, drag out, and remember we're going to type in, this is a radius, so it needs to be half of what we wanted. You could either do 10 divided by 2, and then do space millimeters, or you could just type in the 5, which is half of 10, and there's our polygon for our shape. I'm going to move the arrow until I was looking for the polar coordinate. There we go. There's our basic hexagonal shape, and then it needs to be 6 millimeters deep. So now we're going to hit E for extrude. You could finish sketch and then go to extrude. That's just one more step. You could press the letter E, and then we want to go into it 6 space millimeters. And notice it's coming out. I don't want that. All I got to do is go in front, put the minus sign. Now it goes inside of it, hit enter. There is my basic socket head. So we got our fillet on the bottom, we got our threads, we got our 50 millimeter shank, we got our overall general profile, and then now we've got our recessed portion in here. From this point, these are always, we're going to put fillets in here because they're always rounded off. And they're very, very small. There's not much to them. So we're going to call this a 0.2. Let's see how that looks. That looks good. It was 0.2. Hit OK. So that's a fillet on the inside. We're going to also fillet these two edges, but not yet. So if you notice on a standard or a typical screw, notice this textured portion around the head here. Let me see if I can find a little better drawing, a better part. This little textured portion up here, just to give you something to grip on. So we're going to create that, and we're going to show you another circular profile or circular pattern feature. Alright, so what I want to do is I want to do a create sketch, go to the top of the bolt again, and what we're going to do is we're going to create a little bit of indentation on this edge. This one's not going to be very dimensionally accurate. We're just going to kind of show you how it works. So let's come in here to create. So I've created my sketch, pick the top surface, and I'm going to pick the circle. And I'm going to latch in somewhere on this outer edge, and I'm just going to draw a very small, so let's say a 0.01. And this is in inches. I didn't change it because we're just rolling with it. So we're going to do a 0.01, and then we're going to do an extrusion of that. And you'll notice from the drawing on the screen, it doesn't go all the way down. So we're going to stop just short. And I have this little ridge on the outer portion of the bolt. So if I get it spun around so you can see it. Now that's one, and I need a bunch of them. So what we're going to do now is we're going to hit OK. Notice I'm in the solids menu, not the sketch menu. So when I do create now, but I still have pattern. Come down here to pattern, hit circular pattern, and notice I have a little bit different selection here. I could choose rectangular, I could choose circular, I could choose pattern on a path, but then I have this option to select a body, a face, or a feature. This right here is considered a feature. The bolt currently is a body. If I chose a side, it would be a face, but we're looking at a feature. So select feature, and I should be able to click on this little piece right here. You could zoom in if it's not working. Just make sure that one piece is all that's being highlighted. The axis, we're going to go to axis select, click this outer ring so it knows, and now it's saying 3 of them. That's not how many I want. Let's try 30, see how that looks. That's not enough. Let's try 90. 90 looks good. So we'll type in 90, full distribution, and hit OK. And notice now we kind of have a textured profile. Now, we did this semi-backwards. I think, if I remember correctly, these are actually indentions because they are rolled. But I wanted you to see the circular pattern of a feature. If we did that backwards, let's go back to our extrusion. That last extrusion right here, and instead of clicking the outside one, let's click the inside and do a cut. There we go. We changed it to a cutaway instead of a extrusion. And notice now it's an indentation into the bolt, which is actually closer to true. That looks pretty good. Last two things we want to do is a little fillets right here on the outer edges. Let's click fillet, and then you'll notice when I try to do a fillet, I can't select the whole outer edge. This is where the timeline is going to come in very helpful. So let's roll the time bar back to before that extrusion. Let's do a fillet of this edge, very minor. Say 0.01 inches, hit OK. Do the same thing on the bottom. So we'll type in 0.01, hit OK. And then I'm going to roll my timeline back. And notice that my indentions come back. And that's what I was going for right there. So we got a fillet on the bottom, we got a fillet on the top, we got the fillet right here for stress relief. We're threaded all the way down, and we have a 10mm hex head polygon insert. The last two things I want to do, let's click on, you can do this two ways. You can either highlight over it. The way I did that is I come to the top right, I click the screen and hold it, drag over top of the bolt, it selects the whole thing. When I right click, physical material should come up, and technically we don't need to do this next part. We could just do an appearance because it's already made of steel. So let's just do that. Let's do A for appearance, and we're going to make this black, but I don't want a glossy color. I want a matte finish. Let's go with try this one. So we're going to download this metallic black. See how that looks. If you've worked with these a lot of times they come black. But it's a little too shiny. It's not quite what I was going for. About a powder coated rough. Let's see what that looks like. I don't like the texture on the outside though. There's a lot of options. If we continue to go through the whole entire library, you would see it. I'm going to go back to this one just so it was closest to it. And then if I want this bolt to be more silvery, let's go with the turn all these off. Let's go to metal, coatings. Oh, there's the black oxide I was looking for right there. Let's do that one. There, that's the exact one we wanted. For this one over here, let's go with the chrome, a black home. You can actually play with this however you want. I just want you to change the appearance so that you can see it. There we go. So we've got a hex head 1/2 inch by 13 bolt, and we've got a socket hex head M12 by 1.75. One's 3.5 inches, one's 50. And then just to show you kind of some more realistic views, if you come over here to where design is, top left, click on it and go to render. And let's see if we can. Okay, so it's standing on the floor like that. Do it in canvas rendering. The lighting is not going to be right for this, but it should make it start looking very realistic. If you're doing this part right here on a computer, this may drag your lag down a lot, so you might not want to do this, but I just want to show you what some of the rendering looks like, and you can see what our bolt looks like. Kind of neat. And if you move it, every time I move it, you'll notice it restarts the rendering, so it just takes longer. I don't know if you can hear it on your end. My laptop just kicked in a turbo because it pulls a lot of data, a lot of space to do this. So I just wanted you to see rendering, kind of see what it looks like, realistic. There's a lot of things you can do to play with rendering. We're not going to do so much in this class. So I'm going to hit stop. I'm going to go back over here where it says render, click on that, go back into design mode. And then we want to make sure we save. So I hope you were able to follow along. I know I kind of took some detours there. Apologize for that. But this is how to use polygons, how to create threads, and then you got to see a circular pattern of a feature as opposed to a sketch. All right. So hopefully you get these two completed. Keep them in the same file, and then save them to your folder. We are going to talk about in the near future the difference between bodies, components. Right now, both of these are two individual bodies. We'll make them components when we get into our assemblies. But if you got any questions, shoot me an email, let me know. Thanks for watching.